Hello everyone, today we are starting our class 10th electricity chapter. I hope you are fine today. So we will starting our next class of the class 10th electricity. Okay, this one chapter we will discuss today of class 10. Okay, what is electricity? This one electricity beta, that is related to some basic factor of in our electricity, that is your charge only. Clear? Flow of the charge is there, then electricity will be there, fan is working there, then bulb is blowing there. These all are due to the electricity only. तो बेसिक फैक्टर क्या होता है इलेक्ट्रिसिटी के अंदर? चार्ज होता है. चार्ज विल फ्लो देयर, देन इलेक्ट्रिसिटी विल बी देयर. बट चार्ज फ्लो करने का भी क्या होना चाहिए? एक पैटर्न होना चाहिए. इफ चार्ज आर फ्लोइंग इन अनसिमेट्रिक पैटर्न, दे आर मूविंग हियर एंड देयर, देन current will not flow there, current will be there zero. Okay, for example we are taking any conductor. यहाँ पे हमने क्या है, कंडक्टर ले रखा है. इस कंडक्टर के अंदर चार्ज फ्लो करवा रहे हैं. These charge are moving here and there. कोई इधर जा रहा, कोई इधर जा रहा, कोई इधर जा रहा, कोई इधर जा रहा है. These charge are moving here and there. Then if you can find their average velocity of these charge particle, then average velocity will be equal to zero. So if average velocity of these coming equal to zero, then we can say their current flow through this conductor will be equal to zero. Okay, इस conductor में all conductors are made of the atoms, and atoms is made of the electrons. Electrons are freely revolve around any nucleus. तो यहाँ पे इलेक्ट्रॉन्स है मूव कर रहे, इधर उधर फ्रीली मूव कर रहे, विदाउट एनी एक्सटर्नल फोर्स, विदाउट एनी एक्सटर्नल कट. So they are moving here and there, so average velocity will be equal to zero. Okay, so as we are connecting this one conductor with any source of the battery, then here current we are passing through it, then what happens? All electrons which are moving here and there, they start moving in a symmetric way. जो इलेक्ट्रॉन इधर उधर जा रहे थे वो क्या, सभी एक पैटर्न में मूव करना स्टार्ट कर देते हैं एज वी आर पासिंग थ्रू दिस वन आई. ओके, सो ऑल आर मूविंग इन अ सिमेट्रिक वे, सो एवरेज विल बी नॉट इक्वल टू जीरो. जो यहाँ पे एवरेज वेलोसिटी आएगी वो हमारी क्या आएगी? नॉट इक्वल टू जीरो. सो देयर वी विल गेट सम रिजल्ट ऑफ द वेलोसिटी ऑफ द इलेक्ट्रॉन, दैट मींस करंट विल फ्लो थ्रू दिस कंडक्टर. तो इसके अंदर कंडक्टर के अंदर क्या है, करंट फ्लो कर जाएगा. तो करंट का मेन थिंग्स कहाँ से आई है? चार्ज से. चार्ज विल फ्लो देयर, दैट फ्लो आल्सो शुड बी इन सिमेट्रिक, देन वी कैन से देयर करंट विल बी जनरेट देयर. ओके, सबसे पहले हम चार्ज की बात करते हैं. चार्ज क्या होता है? चार्ज बेटा दैट इज सिंबल इज क्यू ओनली. इट्स सिंबल इज क्यू ओनली. ओके, charge which can, by which we can show that attractive and repulsive nature between them. Charge can be a positive or can be a negative. ओके, चार्जेस क्या होते हैं? पॉजिटिव भी हो सकते हैं और नेगेटिव भी हो सकते हैं. सो इफ बोथ चार्ज वी विल टेक positive positive, one charge we are taking positive positive, then between them force will be act. This one force will call it repulsive force. Okay, if two charge we are taking positive, another we are taking negative charge, then between them force will be act, that will be attractive force. क्लियर? फोर्स का जो नेचर होता है वो टू टाइप का होता है, दैट इज रिपल्सिव और अट्रैक्टिव. इफ टू चार्ज वी आर ब्रिंगिंग नियर विद ईच अदर, बोथ आर सेम पोल, देन वी विल कॉल इट repulsive pole. Same pole, that repulsive force will be there, that can be positive positive, can be negative negative. If we are taking opposite pole, positive negative negative positive, then force between them will be attractive force. तो इसकी प्रॉपर्टी क्या कहती है? चार्ज can be positive and negative. Then first one property of the charge, it can be positive or negative. Okay, we will measure it in minute, then its unit will be SI unit is Coulomb. इसकी जो SI यूनिट होती है वो क्या होती है? Coulomb. Coulomb में हम इसको मेजर करते हैं C will be its unit. Okay, it is our scalar quantity. It is scalar quantity. कैसी क्वांटिटी होती है? हमारी स्केलर क्वांटिटी. Those are having magnitude as well as not having direction. Only magnitude will be there, then we can call it scalar quantity. So some property of the charge we will do there. Properties of charge. Properties of charge. Okay, so properties of charge, here we can write it. Then here first one property, charge is having additive nature. Charge is additive nature. Additive nature, if on any surface many number of the charges are there, here many number of the charges are there, Q1, Q2, Q3 on any conductor, so we can write their total charge Q will be equal to Q1 plus here, Q2 plus here, Q3. Like this one will be there. Next one, charge is having additive nature as well as with it, then charge can be your, if same charge we are taking, same charge repel with each other, but opposite charges attract with each other. Attract with each other. This is the property of charge. अगर दो चार्ज सेम चार्ज को हम पास पास लेके आएंगे, सेम चार्ज we are bringing with near with each other, then they will be strongly repel. ये क्या है? एक दूसरे से दूर भागेंगे अगर सेम पोल लेके आ रहे हैं near with each other. Opposite pole लेके आएंगे, then they will be strongly attracted with each other. Okay. Next point, charge is having conserved nature. Charge is conservative nature. Okay, that is, it will follow the law of conservation of law. Okay, means charge, total charge never be create nor be destroy, it always will be remain conserved. Okay, so we can transfer one form to the another form. कि अगर if we are rubbing two object with each other, तो चार्ज क्या करता है कि एक बॉडी से दूसरी बॉडी पे ट्रांसफर हो जाता है. So this phenomena, the transferring of the current from one charge, one body to another body, that is the induction of the charge. Okay, we are inducing the charge on another body. So this one is nature here, conservative nature, charge will follow conservative nature. Next here, quantization of charge. Next one, quantization of charge. Next here, quantization of charge. Okay, so according to this property, total charge will be there. Fourth one property, quantization of charge. Quantization of charge. Okay, according to this one, total charge available on a body is always in a discrete form. Okay, we can say charge on any body lie in discrete form. Discrete form. Okay, discrete form you can write there frictionless. Okay, that is means you can write there Q equal to NE. From here, where Q will be total charge on the surface. Total charge on surface of any body. Okay, you can say conductor, we can say charge available on any conductor. कितना चार्ज अवेलेबल होगा. टू फाइंड आउट टोटल का चार्ज ऑन एनी सरफेस, then we will write there q. Okay, next will be equal to your n. N is a number of charge particle, number of electrons lie on surface, that will be n. And e will be your charge on electron. Okay, charge on electron, but its value will be 1.6 into 10 raised to power minus 19 coulomb. Its value will be this one. So it is charge on a one electron. So next one here, by which we can say total charge, we can say total charge on any conducting surface will be equal to integral multiple of charge on one electron. Okay, so here we can say total charge equal to your q equal to ne. N is the number of the electrons which are lying on the surface, then your e will be electron, then total charge will be this one. Okay, for example we can say, then question is there, if 5 electrons lie on a conducting wire, then find total charge. Find total charge on this wire. Okay, if your 5 electrons lie on the conducting wire, if wire has इसके ऊपर क्या है, 5 electrons are there, one wire conducting wire is there, on this one 5 electrons are there. तो ये पूछ रहे कि इसके ऊपर कितना चार्ज लाई करेगा. फॉर बाय यूजिंग क्वांटाइजेशन ऑफ चार्ज, टोटल चार्ज ऑन एनी सरफेस विल बी इक्वल टू इंटीग्रल मल्टीपल ऑफ द नंबर ऑफ द electron. Okay, so integral multiple of the charge on the one electron. So we know about this one. Your solution we can write there. So how many number of the electrons? Number of electrons, and we can write there equal to your 5. Okay, so conducting 5 electrons are available. Then we know about this one, charge on one electron. Charge on one electron, it will be 1.6 into 10 raised to power minus 19 coulomb. Minus 19 coulomb. So we have to find out charge on 5 electrons. So how we can find charge on 5 electrons? Equal to q equal to your ne according to quantization of charge. So here q equal to your ne. So total charge we can write there q, number of electron 5 and electrons 1.6 into 10 raised to power minus 19. So here we can write there 8.0 into 10 raised to power minus 19 coulomb. Q will be equal to this one. Okay, it will be total charge available on any conducting surface. कि किसी सरफेस पे 5 इलेक्ट्रॉन्स लाई कर रहे हैं, उसके ऊपर आपको टोटल चार्ज अगर फाइंड करना है तो कैसे फाइंड करेंगे? Q इक्वल टू NV. N हमारा क्या होगा? नंबर ऑफ द चार्ज पार्टिकल अवेलेबल ऑन इट, देन लाइक दिस वन वी कैन फाइंड इट. ओके, अनदर क्वेश्चन, लेट्स सी. charge on conducting wire is 3.2 into 10 raised to power 24 minus 24 coulomb. Then find number of electrons lies on conducting wire. So how we can find this one number of electrons? So here question, in your question now this time given beta charge. अब आपके पास टोटल चार्ज गिवन है, किसी सरफेस के ऊपर चार्ज इतना होगा, द नंबर ऑफ इलेक्ट्रॉन, हाउ वी कैन फाइंड इट? So again we can apply there beta this one here given your charge on the conductor, total charge given is 3.2 into 10 raised to power minus 24 coulomb. Total charge is given this one. So आपको क्या फाइंड करना है? n फाइंड करना है. What is the number of the electrons which lie on the conducting wire? So how we can find them? So according to the quantization of the charge, according to quantization of charge, then we can write there Q equal to your N. So Q equal to given here 3 point into 10 raised to power minus 24 coulomb आपको given है, and we have to find क्या करेंगे? E will be equal to your number of electrons here. We can put value of E. E equal to your 1.6 into 10 raised to power minus 19 coulomb. ये आपको given है. N आपको find करना है. So for N, then we can write that 3.2 into 10 raised to power minus 24 coulomb divided by 1.6 into 10 raised to power minus 19 coulomb. Clear? So as we will solve this one, then cancel it 3 to ja. Then 19 to this one cancel out, then here left here 5. Okay, 10 raised to power minus 5. These electrons are available on our surface. Number of electrons. Okay, so like this one we can find beta. Here formula is quantization of charge Q equal to any, then two way, then we can find total charge, we can find number of the electrons which are available on our surface, conducting surface. So next one beta, we will start our electric current. Electric current. Electric current, that is symbol is I only we will use. What is electric current? Now we done their charge. Now current will be there. It is defined as flow of charge. Flow of charge per unit time is known as electric current. Clear? The charge flow करता है in how much time, then we will call this one your electric current. So here we can write by using this one mathematically, we can write there I equal to flow of charge beta Q per unit time, that means divided by time we are writing there. By using definition you can say I equal to Q by T. Q is a flow of charge per unit time. So I equal to Q by T. So by using this formula we can write its unit also. It's SI unit. It's SI unit. We will measure this one in your ampere unit only, but ampere only. Okay, but by using this formula we can write it here. Q is a charge unit I told you coulomb, and time is there second. Okay, so another unit you can write there coulomb per second also, unit of this electric current. Electric current is a flow of the charge per unit time is known as a electric current. Flow of charge, how much charge is flowing there, then current will be this one. So SI unit will be ampere per this one. Okay, it is our scalar quantity. What it is? Scalar quantity. Scalar quantity. Your quantities are having two types, scalar or vector. So I will be our scalar quantity, depend upon your charge and current. Charge is scalar quantity, time also scalar quantity. So as we will divide scalar quantity to scalar quantity, then we will get their scalar quantity. Okay, then you will say beta its direction is having. इसकी direction क्या होती है? Its direction from positive terminal to नेगेटिव टर्मिनल, टर्मिनल ऑफ सेल। ओके, जो करंट हमारा फ्लो करता है वो पॉजिटिव से नेगेटिव फ्लो करता है। अब ये कहेंगे कि अगर इसकी डायरेक्शन है पॉजिटिव से नेगेटिव, फिर भी डायरेक्शन होते हुए भी क्या स्केलर क्वांटिटी है, बिकॉज बेटा दिस इज नॉट फॉलोइंग, दिस मीन एक्सेप्शनल केस, इट इज नॉट फॉलोइंग रूल ऑफ द वेक्टर। ओके, इट इज नॉट फॉलोइंग rules of vector addition। वेक्टर को ऐड करने के लिए बेटा कुछ रूल होते हैं, जिन रूल को ये करंट फॉलो नहीं करता। जो क्वांटिटी ना कि सिर्फ मैग्नीट्यूड और डायरेक्शन, बट अगर डायरेक्शन के साथ साथ उनको क्या है वेक्टर्स के रूल भी फॉलो करने चाहिए, तभी क्या होता है वो वेक्टर क्वांटिटी होती है। तो क्या है इसका मैग्नीट्यूड भी है, डायरेक्शन भी होते हुए भी इट इज नॉट वेक्टर क्वांटिटी, बिकॉज इट इज नॉट फॉलोइंग द रूल ऑफ द वेक्टर एडिशन। वेक्टर एडिशन के रूल नहीं फॉलो करती, दैट्स व्हाई वी आर कॉलिंग इट स्केलर क्वांटिटी। ओके, सो करंट हमारा क्या होगा, फ्लो ऑफ चार्ज पर यूनिट टाइम, यूनिट एम्पियर, देन इट इज स्केलर क्वांटिटी, डायरेक्शन पॉजिटिव टू नेगेटिव। So how we can measure this one amount of the current? This one we can measure with help of the its value measured by a device that is called ammeter। What? ammeter। ओके, किसी सर्किट के अंदर कितना करंट फ्लो कर रहा है उसकी वैल्यू को मेजर करने के लिए, करंट की वैल्यू मेजर करने के लिए हम जिस डिवाइस का यूज करते हैं वो क्या होता है हमारा एमीटर होता है, विच इज कनेक्टेड इन सीरीज, विच इज कनेक्टेड इन सीरीज in our circuit। Okay, here where we want to find the value of electric current, there we will connect the ammeter। और ammeter को हमेशा किसमें कनेक्ट किया जाता है, सीरीज में कनेक्ट किया जाता है, to find the value of the ammeter। Okay, so इसके अलावा एक और डिवाइस होता है बेटा गैल्वेनोमीटर। गैल्वेनोमीटर it is used to detection the value of the electric current। Okay, गैल्वेनोमीटर, but गैल्वेनोमीटर ओके, गैल्वेनोमीटर भी होता है। गैल्वेनोमीटर क्या होता है, वो डिवाइस होता है जिसका हम यूज करते हैं करंट को डिटेक्ट करने के लिए कि इन एनी वायर करंट इज फ्लोइंग देयर और नॉट। ओके, सो फॉर डिटेक्शन इट इज यूज्ड टू डिटेक्ट द वैल्यू ऑफ इलेक्ट्रिक करंट in any circuit। किसी सर्किट के अंदर क्या है आपका इलेक्ट्रिक करंट प्रेजेंट है या नहीं प्रेजेंट है, तो इसके लिए हम क्या यूज करते हैं गैल्वेनोमीटर का यूज करते हैं। ओके, सो गैल्वेनोमीटर इट इज यूज्ड टू डिटेक्ट देयर वैल्यू ऑफ द इलेक्ट्रिक करंट, देन वी आर यूजिंग देयर गैल्वेनोमीटर also we are using in a series in our circuit diagram। सर्किट के अंदर इसको भी, so here we can write their galvanometer is a more sensitive, galvanometer is more sensitive as compared to the ammeter। जो गैल्वेनोमीटर है वो हमारा ज्यादा सेंसिटिव होता है एज कंपेयर टू दी एमीटर। ओके, बिकॉज एज वी विल कनेक्ट देयर गैल्वेनोमीटर इन एनी सर्किट, देन वेरी स्मॉल अमाउंट ऑफ द करंट विल बी देयर, देन इजीली वी कैन डिटेक्ट विद हेल्प ऑफ द गैल्वेनोमीटर, बट एमीटर will not give reading of this small amount of the electric current। Okay, so we can say ammeter galvanometer is a more sensitive as compared to the ammeter। Okay, now see their question है, find a 3 into 10 raised to power 6 Coulomb charge flow in conducting wire for 10 seconds, then find इलेक्ट्रिक करंट। ओके, क्वेश्चन के अंदर कह रहा है अगर ये चार्ज इतना चार्ज फ्लो कर रहा है फॉर द 10 सेकंड, देन व्हाट इज द वैल्यू ऑफ द इलेक्ट्रिक करंट। सो हाउ वी कैन फाइंड बेटा, सो एज वी नो फर्स्ट वी विल राइट द formula which you know about this one. So here given here, write all quantity which are given in our question here. First your charge is given. Okay, charge given. What is the value of charge? 3 into 10 raised to power 6 coulomb. This is the value of charge which are available in any conducting wire, and in which this charge is flowing for a which time? Your time is given here, t equal to your 10 second. Clear? If this charge is flowing for this one time, then we have to find out what is the value of the electric current. तो आपका करंट क्या हो जाएगा? So करंट फाइंड करने के लिए what is the value of electric current, this we have to find out. So as we know, first beta read your question carefully, then write all the quantity which are given in your question. Okay, then think how you can find, by which formula you can find their quantity which you want to find out, which formula we can apply, then write all formula. If you can't identify, then check there which one we can use there. So first, what is the relation? We will write the formula which is explaining the relation between these quantities all. ओके, सो चार्ज गिवन, टाइम गिवन, आई गिवन. सो हमें पता है कि आई क्या होता है चार्ज की फॉर्म में, करंट फ्लो पर यूनिट टाइम इज नोन एज द इलेक्ट्रिक करंट. यस और नो? फ्लो ऑफ चार्ज पर यूनिट टाइम is known as the electric current. So your charge given, time given, then current, how you can find? Your charge is here 3 into 10 raised to power 6 divided by your 10. 10 second is there. So here we can write there 3 into 10 raised to power. When we will solve this one, then here we'll left here 5, then here 3 into 10 raised to power 5. This is the charge available on the conductor. Here, sorry, ampere. Current is there, no? This one here, ampere. Okay, this one current will flow through any conductor. अगर ये चार्ज अवेलेबल है, ये टाइम अवेलेबल है 10 सेकंड के लिए, तो हमारे पास करंट क्या आ जाएगा? 3 into 10 raised to power 5 एम्पियर. ओके, सो दिस वन इज अ टोटल करंट फ्लो थ्रू दिस सर्किट. Like this one, another question if we are taking there, if ten electrons present in any conducting body, then find electric current. When these electrons flow for 20 seconds. हमारे पास कितना है क्वेश्चन में? कह रहा है कि 10 इलेक्ट्रॉन्स आर प्रेजेंट ऑन द कंडक्टिंग बॉडी. 10 इलेक्ट्रॉन प्रेजेंट है किसी कंडक्टिंग बॉडी के ऊपर. देन फाइंड द इलेक्ट्रिक करंट. इलेक्ट्रिक करंट वी हैव टू फाइंड आउट व्हेन दीज इलेक्ट्रॉन फ्लो फॉर द 20 सेकंड. वी हैव टू फाइंड आउट इलेक्ट्रिक करंट. इलेक्ट्रिक करंट फाइंड करना है अगर आपके पास 20 इलेक्ट्रॉन्स, सॉरी 5 इलेक्ट्रॉन्स given, a 10 electrons flow for the 20 second. So how we can find this one again beta? So here we can find there, first write all the given quantity. Which quantities are given in our question? First we will write there. Electrons, 10 electrons are there, means number of electrons are given here. Number of electrons are given there. Number of electrons and given here 10. Conducting on the body, then find the electric current when these electrons flow for the 20 सेकेंड. जब ये इलेक्ट्रॉन क्या है 20 सेकेंड के लिए फ्लो कर रहे हैं, तो आपको क्या निकालना है? इलेक्ट्रिक करंट निकालना है. क्लियर। सो इलेक्ट्रिक करंट हमें फाइंड करने के लिए हमें क्या चाहिए, टोटल चार्ज ऑन दी कंडक्टर, बट हमारे पास टोटल चार्ज है ही नहीं, क्या गिवन आपके पास, नंबर ऑफ इलेक्ट्रॉन्स गिवन है। सो फर्स्ट वी नो अबाउट दिस वन, I इक्वल टू हियर Q by T। ओके, तो I इक्वल टू Q by T, Q इज नॉट गिवन हियर, तो फर्स्ट वी शुड नो अबाउट देयर Q। अब Q कैसे निकालेंगे, अब Q हमें पता है कि टोटल चार्ज, हाउ वी कैन फाइंड। So as we know, we have done already quantization of charge. Quantization of charge क्या देता है हमें, टोटल चार्ज देता है किसी कंडक्टर के ऊपर कितना चार्ज अवेलेबल है। So about this one we know total charge, we know about this one Q equal to here and E, number of electrons which are available on any conducting surface into charge on one electron. Okay, so Q we can write there, Q equal to here number of electrons are present here 10 and charge on electron into 1.6 into 10 raised to power minus 19 Coulomb. Okay, so here 10 to 16, then here we can remove this one dot, then cancel out, then here left here 16 into 10 raised to power minus 19 Coulomb. तो ये हमारे पास क्या आ गया, टोटल चार्ज आ गया। टोटल चार्ज आ गया तो हमारे पास क्या है, करंट आ जाएगा, टाइम गिवन। सो हेयर वी कैन राइट देयर I इक्वल टू हियर Q by T, I इक्वल टू Q by T। Q हमारे पास क्या आया, 16 into 10 raised to power minus 19 Coulomb divided by your T, T equal to your 20 second. Okay, so when you will solve this one, here we can write it 1 0 to 1 0 they cancel, then here left here 8, here 8 into 10 raised to power, it will be equal to 10 raised to power minus 20 only. Clear, because here 2 into 10 we can write there here minus 19, तो यहाँ पे क्या हो जाएगी, पावर माइनस में चली जाएगी, एक और ऐड हो जाएगी, तो हमारे पास क्या बचेगा 8 into 10 raised to power minus 20 एम्पियर। Okay, I hope you understood beta this question. If your current here, current we have to find out, charge per unit time, charge अगर given ना हो, then we will think about another formula, by which formula we can find value of the charge there. तो चार्ज की वैल्यू हम फाइंड करेंगे, कहाँ से फाइंड करेंगे, बाय यूजिंग क्वांटाइजेशन ऑफ चार्ज, Q इक्वल टू हियर N। N आपको गिवन है, E will be charge on one electron, so it will be equal to 10 into 1.6 into 10 raised to power minus 19। सो इसको सोल्व करके कैंसिल करेंगे तो आपके पास Q क्या बच रहा है, 16 into 10 raised to power minus 19 Coulomb। So put value of Q here, then divide by T, then 8 will become equal to this one 8 into 10 raised to power minus 20 ampere. This one current will flow through this conducting wire. Okay, so we discussed there two formula, one is of the charge and second we discussed there current. Okay, first we discussed there Q equal to your Ne, second we discussed there I equal to Q by T. Clear? If your Q is not given, then we can write it Ne by T also. Okay, so next here from electric potential. What? Electric potential. Electric potential, this one we will denote with a symbol, its symbol is capital V. What is electric potential? Potential means related to our capacity. ओके, अगर हम कोई काम कर रहे हैं तो हमारे अंदर कितनी कैपेसिटी है, व्हाट इज अ पोटेंशियल, हमारे अंदर कितना पोटेंशियल है टू डू एनी वर्क, कि अगर हम कोई काम कर सकते हैं तो हमारे अंदर कितना पोटेंशियल है, दैट इज हियर our capacity doing work. Okay, so here we are talking about the charge, talking about the current, that's why here we are talking about their electric potential. तो यहाँ पे हमारा क्या है, इलेक्ट्रिक पोटेंशियल। इफ वी आर डूइंग देयर work in a motion, then we will call it mechanical potential, potential energy like this one. So here electric potential related to your charge only. So this one, it is defined as, if it is defined as total charge, total work done by any charge by any charge from one point to another. Okay, otherwise you can say from infinity to reference point. Okay, this one is known as electric potential. Electric potential क्या रहेगा? Total amount of the work done by any charge. कि एक point से दूसरे point तक charge को आने में, let here charge is there and another test charge Q naught. This one our test charge. What is the meaning of test charge? Small charge coming from here to there. कि एक कोई small charge है, test charge है, coming from one to another point, A से B तक आ रहा है. तो यहाँ से यहाँ तक आने में उसके ने जितना भी वर्क किया, जितने भी by this charge Q naught, then this one is known as our electric potential. Okay, so here we can write it mathematically. Work done by this charge is known as the potential. If here we are writing their Q naught, then here we can write their Q naught only. Work done by this charge is known as the electric potential. So we can write total work done by any charge from one to another point. Here one point is A, second point is B. Maybe this point can become from the infinite to any reference point, means here given point. So here we can write there B equal to W by Q. Okay, so by using this one, its unit will be, its unit is what? Volt. Small v. Or by using this formula, we can write their work done. Work done unit will be a joule only. So joule per coulomb will be unit of the this one. Okay. So by using, if you want to find work done, then work done we can write there P into Q. Okay. So this one here, it is our scalar quantity. It is scalar quantity. It is scalar quantity. And it always we will connect in parallel. Okay, how we can measure this one? It is measured with help of device that is voltmeter. Okay, which is connected in parallel. It is connected with the parallel with resistance. ओके, डिवाइस के साथ वोल्टमीटर हमेशा क्या होता है, पैरेलल में अटैच करते हैं. दैट इज यूज्ड फॉर द वैल्यू ऑफ द इलेक्ट्रिक पोटेंशियल. कितना पोटेंशियल का ड्रॉप हुआ है इसकी वैल्यू फाइंड करने के लिए हम जिस डिवाइस का यूज करते हैं, दिस वन हियर वोल्टमीटर. ओके, एमीटर वी आर यूजिंग फॉर द फाइंड द वैल्यू ऑफ इलेक्ट्रिक करंट, जिसको हम सीरीज में अटैच करते हैं. वोल्टमीटर वो डिवाइस होता है जिसको हम पैरेलल में अटैच करते हैं इलेक्ट्रिक पोटेंशियल की वैल्यू फाइंड करने के लिए. Okay, so here we discuss beta there different term. One your charge we define there, then second we have done current is a flow of your charge per unit time. Next will be your electric potential. Electric potential is a work done by any charge. Okay, work done, how much work is done by any charge. This one your electric potential going from one to another potential point. Then volt is SI unit joule per second. Then it is scalar quantity measured with help of the voltmeter. So next here, as we are merging all them, as we will merge all three terms I and here B. Okay, so here we will get their one law, that is your Ohm's. According to Ohm's law, then potential, electric potential will be directly proportional to the electric current. Okay, so here we can write there according to Ohm's law, electric potential is directly proportional to electric current. Okay, so mathematically we can write this one, V is directly proportional to I. Means any device we are attaching here whose resistance that we are taking there R, then this one here we are attaching this one battery. Then here for the value of the current we will attach their ammeter. then V will the voltage. Okay, resistance is R. So we are passing through this one. As battery we will connect here. Here we can connect their key. Here key. Okay, in this one dot we will use, that is here switch on. If dot we will remove, then it is off. So as we will switch on, then current will start flowing through this one. Then here we will connect a voltmeter to measure the value of the voltage. Here this one here ammeter, we are attaching the value of the current. So voltmeter in parallel, and this one we will connect in series, and this one our resistance, by which we want to find out the relation between V and I. So according to this law, V will be directly proportional to this I. Then remove this proportional sign. Then here we will take a one constant, and this one constant we will take here resistance. With the name of this one resistance. So what is resistance? It is a device which oppose the flow electric current is called resistance. Clear? Resistance हमारा वो डिवाइस होगा जो करंट का अपोज करा. This one we will denote with R only, and its symbol will be like this one. So by using this one, we can write there V equal to IR. This is the relation between your potential, electric current, and the resistance. Okay, by this one we can say those devices which follow the Ohm's law, then we will call them ohmic devices, and which are not following Ohm's law, then we will call them non-ohmic devices. Okay, so today revise this one topic till here only. Then next topic we will do in next class. Thank you for watching today our video.